Hello, so today we are doing this problem called largest perimeter triangle, and it's an easy problem. So the problem says that we have an array A of positive length, and we want to return the largest perimeter of a triangle with a non-zero area. So this is bold, so that means it's important. So it's for that we want the triangle with the largest perimeter that is formed from these three lengths of this triangle. And if we can't have a non-zero area, then we can return 0. And these are the examples of the list that we have. And we are guaranteed that the length is going to be either equal to 3 or above. So that's good. Okay, so let's see how can we solve this problem. So the condition said the triangle area has to be bigger than 0. So for this to happen, we just need to have one side of the triangle that is less than the sum of the other two sides, and we need them to be like this. So the biggest one needs to be the longest side needs to be less than the sum of the two other sides. That's what we need to get an area that is bigger than 0. So how can we achieve this? So we have this already, so we know we need to sort. So we can just sort first the list. And once we sort it, we can look for something that verifies this condition. So since it's sorted in ascending order here, we need to go from the last, from the end of the list. So let's go from the end -3, and we keep going down until we reach -1. And since this is exclusive, that means we'll stop at 0, right? So what do we want to do? So we are taking -3 so that we can check if AI plus, so if I is n-3, then I plus 1 is n-2, and I plus 2 is n-1, which is the last element of the array. So that's why we want that. And so if we check I-1 and check that this is bigger than I plus 2, so since the array is sorted in ascending order, that means that this is the biggest value. So this kind of is the equivalent of C in our case here, since it's the biggest value. And +1 is the equivalent of B here, since it's the second largest one. And AI is the equivalent of A in our case here. So if we have this, which means we have this condition, let me just write it in a way that makes the mapping clear. So if we have this C here that is less than A plus B, then we have our condition, right? So we can just return the sum of these, which is AI plus AI -1. Sorry, here it's +1. AI +1 plus AI +2. Alternatively, we can just use Python's sum, which gives us I until I plus 3, basically. And if we couldn't find one, then we return 0, which is what the problem said over here. We need to return 0 if it's not the case. So let's run this and see if we have a solution. Okay, so that passes. Let's keep trying on other cases. Okay, so it passes on that one. Let's try on this one. Let's try on this one too. Okay, let's try another. Okay, let's just submit and see if we can get it. Okay, so that works. So another way we can do this, which is, so here we just kind of, what we need is just the tuple of the element next to it, and the element after that. So we can explore that here. So instead of doing that, we are going to just construct an array of A plus B plus C, which is the perimeter if we find such a tuple. And then these values, we are going to take them instead from a zip of A, A1, and A2. So what does this give us this here? Let's take this array, for example, right? Let's say A is equal to this, and let's sort it first. And so A now is sorted. If we take A1, this will give us everything except the first element. If we take this, it will give us everything except the two first element. Now, if we zip this with this, so if we zip these three, let me show a list. So we get a tuple of basically of 2, 3, 3, and then of 3, 3, 4. So we get the same thing we did earlier by using I plus 1, and I plus 2. So now that we have these, we can just check if the condition that we want for the area to be bigger than 0 is, which is this condition here. We can just check that one. This condition is already verified since we sorted the list. So we just need to find a tuple of ABC that verifies this condition. And then, so that we can just write it as it is. So with list comprehension this way. There is only one problem, is we might not find such a tuple in cases where the area is 0. In that case, we need to return 0. So what we can do is put this in a list, and then we can return 0 if we didn't find anything, which is if the length of res is equal to 0. Otherwise, we can just return the last element here, which is what we are. So if we have multiple, can get the last element, the biggest one, basically. Okay, so let's run this. That works. Let's submit. That works. Another nice trick that we can do, instead of having, just to make the code a little bit shorter, if you prefer that, is to, instead of doing this, we could just bring, and doing this if else, we can just bring this here. So what will happen if this is empty? We could just append a 0, which means that if this is empty, then this is then getting -1 of this will give us the last element, which would be 0. But if this is not empty, then we will just get the last element of this, which is what we did earlier. And so this will cover all cases. And that passes. Okay, thank you. See you next time. Bye.